All right, let's dive right in. Today, we're going to build an API from the ground up using one of the most powerful and cost-effective tools in the AWS world, API Gateway's HTTP APIs. We're going to cover the whole journey from the first sketch on a napkin all the way to a secure public launch. This is the complete playbook.
So let's start with a problem that, every developer runs into this, right? You've built your awesome backend logic. Maybe it's a Lambda function, could be a container, and now you need to get it out to the world. And the checklist is always the same. It's got to be fast, it absolutely has to be secure, and you really, really don't want it to cost a fortune. So how do you actually do that?
Well, this is exactly where HTTP APIs come into the picture. For years, the main option on AWS was the classic REST API. And don't get me wrong, they're fantastic. They are packed to the brim with features like API keys, usage plans, deep WAF integration, you name it. But all that power comes with a higher price. HTTP APIs are the newer, more streamlined sibling. They're lean, they give you the essentials you need, which means they come in at a much lower price. This makes them pretty much perfect for serverless apps or just creating a super fast, simple front door for your existing HTTP backends.
To really get a feel for how these work, let's walk through it together, like we're building one right now. Every great API starts with a solid plan, a blueprint. And the very first step is defining that front door, how your API is going to understand every single request that comes knocking. And that front door is built with something called a route. The best way to think of a route is as a specific address. It combines an action, the HTTP method, like get to read data or post to create it, with a location, which is the path, like /pets. You put them together and boom, you've got a unique entry point for one specific job your API does. And as you can see from these examples, it's super intuitive. A request for get/pets hits that route. Simple. If you need to grab one specific pet, you can use a path variable, like that pet ID. So a call to /pet/6 gets routed to the right logic automatically. And then there's the really powerful $default route. This thing is a catch-all. Any request that doesn't match another specific route you've defined, it lands here. This is a lifesaver for things like proxying a bunch of paths to an old system or just giving a friendly not found message. Okay, so we have our routes. We've defined all the doors into our API. But where do those doors lead? That brings us to the next stop on our tour, the engine room. This is where your actual code, your business logic lives and does its work. And that connection is called an integration. It's the wiring. It's the essential piece that connects a specific route on the outside to a specific back-end resource on the inside. This is the bridge that takes a request from the public internet and hands it off to your private code that's going to do all the heavy lifting. So the flow is really simple and direct. A client calls your API endpoint. API Gateway matches the request to the right route. The integration for that route then forwards the request over to your backend. Let's say it's a Lambda function. Your function runs its code, does its thing, queries a database, whatever. Then it passes the response right back through that same integration, and API Gateway sends it straight back to the client who asked for it. It's just a clean, efficient round trip. And you've got options for what that backend can be. The most common one is probably a Lambda proxy integration, which is just perfect for serverless apps. You can also use an HTTP proxy to just pass requests along to any other web server, which is great if you're trying to put a modern face on an older application. Or you can get really clever and integrate directly with other AWS services. Like you could have a route that sends a message straight to an SQS queue or kicks off a step functions workflow, all without you having to write a single line of backend code. It's pretty cool. All right, so we have a working API. That's awesome, but we can't just leave the front door wide open. We need a bouncer. Security is absolutely non-negotiable for any API, and luckily, HTTP APIs give you some really powerful ways to control who gets in. You've basically got three main flavors of security. You can use Lambda authorizers for totally custom, roll-your-own logic. You can use JWT authorizers for modern, standards-based authentication. Or you can use native AWS IAM for service-to-service security. Let's break those down real quick. The Lambda authorizer is your most flexible option, hands down. You write a separate little Lambda function whose only job is to be a security guard. It inspects the incoming request, runs whatever logic you want, maybe it checks a cookie, looks up a key in a database, and then it just returns a simple allow or deny. You have total control. Next up, JWT authorizers. Now, if you're using a modern identity provider that gives you JSON Web Tokens, think Amazon Cognito, Auth0, Okta, that whole world, this is definitely the way to go. You just tell API Gateway about your provider, and it handles all the heavy lifting of validating tokens for you. It's a really robust industry standard approach. And finally, there's IAM authorization. This is the native AWS way of doing things. It uses the same roles and policies you're already familiar with, from managing access to S3 buckets or EC2 instances. This is absolutely perfect for internal service-to-service communication within your AWS account.
Okay, we've built it, we've secured it, our API is ready for its big debut, it's opening night. This last step is all about getting it out to the world, making it look professional, and making sure it can handle the crowds. To actually publish an API, you deploy it to something called a stage. A stage is just a named snapshot of your API's configuration. Like dev, beta, or prod. This is so important because it lets you work on new features in your dev stage and test them out without ever risking your stable, customer-facing prod stage. Now, when you deploy to a stage, AWS gives you this default URL. And, well, you can see it. It works, sure. But it's long, it's ugly, and it's not exactly something you'd want to put on a business card. Thankfully, you can fix that very easily with a custom domain name. You can map a nice, clean, professional URL like api.example.com directly to your API stage. I mean, the difference is night and day. It just makes your API so much easier for people to find and use. Okay, one last thing before we throw open the doors: protection. Throttling is your API's defense mechanism. It lets you set limits on how many requests can come in over a certain period. Think of it like a valve that protects your backend from getting slammed, whether that's from a sudden burst of popularity or something more malicious. And you get really fine-grained control here. For example, you could set a standard route, like getting a list of pets, to a high limit, maybe 2,000 requests per second. But for a really expensive operation like generating a big report, you could set a much, much lower limit to protect your backend resources. It keeps everything healthy and stable for all your users. So there you have it. That's your complete toolkit for building with AWS HTTP APIs. We've seen why you'd use them. They're fast and low cost. We've seen how you build the blueprint with routes, connect to the engine with integrations, hire a bouncer with authorizers, and finally, launch to the world with stages and custom domains.
At the end of the day, HTTP APIs are a powerful, simple way to connect your code to the world. They handle all the messy, complicated stuff at the front door so that you can focus on building what's truly valuable inside. So the only real question left is this: your backend is ready? Who are you going to connect it to?